Hi, today we are going to solve this integral from an exam first year from MIPT. And we will do it using partial fractions. So we want to present this fraction, x squared plus 2 divided by x plus 1, x squared minus 2x plus 3, like some of other fractions. So let's see what it will be here. Sum a divided by x plus 1 plus here will be b multiplied by x plus c divided by x squared minus 2x plus 3. So let's see what we'll obtain here. So I rewrite this line, and then we can see that we need to multiply our a by x squared minus 2x plus 3, and we need to multiply this numerator bx plus c by x plus 1. Of course, I should write denominator here, and we can see that this denominator and this denominator are equal, so that means that this part and this part are equals to. I'll take another one, but no, not very good too. So that means that x squared plus 2 equals 2, and here let's rewrite it a little bit. A multiplied by x squared minus 2ax plus 3a plus bx squared plus cx plus bx and plus c. And, well, little bit more organized, I want to write it so x squared, here and here we will have a plus b, then plus x minus 2a plus c plus b from here, and then plus 3a plus c. So let's see. Here we have x squared, and here we have x squared. So this is equality. So we understand that here we have 1, so this part will be equal to 1. Next, in this part we have no x, so all this line will be equal to 0. And here we can see that also 3 plus c equals 2. Let's write it in a system. So a plus b will be equal to 1, then minus 2a plus c plus b will be equal to 0, and 3a plus c will be equal to 2. And now we need to solve this system of equations. So what we can do here? Well, actually there are different ways. We can, for example, take from here a, or I think it will be better than I will take b. b will be equal 1 minus a from first line, and from third line, well, I will obtain C, which is equal to 2 minus 3A. Now, all this line, first and third, goes to the second one. And we will obtain what? Minus 2A plus C. But C equals to 2 minus 3A, then plus B. But B equals to 1 minus A. And it equals to 0. So now we have only A here, so we can solve our equation. Minus 2A minus 3A minus 5A minus A minus 6A, 2 plus 1, and there goes here, so it will be minus 3. And we will divide this line by minus 6, so A will be equal to 1 divided by 2. Then, from here, from first line, here will be first, second, and third. From first line, we can obtain our B. B will be equal 1 minus A, where A is 1 divided by 2, and it gives us 1 divided by 2. Yes, our B is 1 divided by 2, our A is 1 divided by 2, and now from third line, we can obtain C. Let's see, it will be 2 minus 3A, 3 multiplied by 2, 1 divided by 2, I'm sorry, and it will be 2 multiplied by 2, 4 minus 3, 1 divided by 2, 2, okay. Then we can move here, and let's see what we will have from here. From here, we will have that this line, x squared plus 2 divided by x plus 1, and x squared minus 2x plus 3 will be equal to a divided by x plus 1. So it will be 1, 2 I'll put here, and x plus 1. So a is our 1 divided by 2. Then plus bx plus c. Bx, 1 divided by 2, x plus 1 divided by 2 divided by x squared minus 2x plus 3. And here actually, here I can write it a little bit more nice. 1 divided by 2 multiplied by, from here and here, 1 divided by 2, x plus 1, and here x squared minus 2x plus 3. So now we finally can solve our integral. Let's do it. Let's do it. So we have integral of this function, and this function presented like this one part plus this part. So it will be 1 divided by 2 from here, then dx divided by x plus 1, then plus 1 divided by 2 from here, integral of x plus 1 dx divided by x squared minus 2x plus 3. So now we need to solve these integrals. This one is very simple. It's actually a logarithm. And here we need to think a little bit what we want to do here. So let's see. If we write dx squared minus 2x plus 3, it will be equal to x squared minus 2x plus 3 derivative dx, and it will be equal to 2x minus 2 dx. And here we can see x, it's very good for us, and we can add something or subtract something. Let's do it. So I will rewrite this line. 1 divided by 2 integral dx plus 1 x plus 1 plus I want to multiply our numerator by 2, so I divide our line by 2. So here we obtain 1 divided by 4 integral. Well, then here will be 2x plus 2, but we want to have here minus 2. So we write minus 2 and plus 2 again, because this sum equals to 0. So we shouldn't change our line. And here we rewrite our denominator and, of course, dx. So then again, I quickly rewrite this line, and we can from here obtain two integrals. Look, this part and this part divided by this line, 1 divided by 4 integral 2x minus 2, like here, and dx, x squared minus 2x plus 3. Then, well, what else remains? 2 and 2, so it will be 4. 4 divided by 4 gives us 1, so it will be integral of dx divided by x squared minus 2x plus 3. Then, what should we do next? So, of course, I can do integration, but I want to do it at the end. So here we have 1 divided by 4 integral d of, look, x squared minus 2x plus 3 divided by x squared minus 2x plus 3, then plus. Here, what we should do here? Here we can see that we can represent this line like x squared minus 2x plus 3. We can write like x squared minus 2x plus 1 plus 2 from here. 3, we can write this line. And we know that x squared minus 2x plus 1 gives us x minus 1 squared plus 2. Why we do that actually? Because we have a formula of integral of dx divided by x squared plus a squared. It's a number, and we know that this integral equals to 1 divided by a arctangent of x divided by a plus c. This is a formula. So now we want to use this formula, and we want to represent this line in our denominator like this. So let's do it. We will write integral of, here will be dx minus 1. We can do it because of derivative of constant gives us 0. And here will be x minus 1 squared plus square root of 2 to the power of 2. It's equal to 2 actually. And we can see that our a is square root of 2, and this part is this part. So finally, now we can obtain our answer. Let's write it. 1 divided by 2, logarithm of absolute value x plus 1 plus 1 divided by 4, logarithm of absolute value x squared minus 2x plus 3 plus, now 1 divided by a, 1 divided by square root of 2, then arctangent, and then x divided by a. But here we have no x, we have x minus 1, so here will be x minus 1 divided by square root of 2, and of course we need to write here constant from real numbers. So this is the answer to this question, this integral from an exam from MIPT for first year students.